All right. Hello, everyone, again. And today we'll be talking about, hello, everyone. So today we'll be talking about how to implement basically an OSINT AI agent that will aid your investigations, that will help you to find the pathway in the investigations. And also we'll talk about different technical approaches, how this can be achieved, the challenges that are ahead, and how we at ProPoint Analytics are trying to overcome them. My name is Vasily Popa. I am the CEO and founder of the ProPoint Analytics. And I want to start first a bit with the background about ourselves, our team. We are a team of investigators, of OSINT specialists, slightly from different areas. So we are a team of software developers, investigators, people with the law background and professional in that area. And we all been also part of the OSINT for Ukraine Foundation. We were one of the founders and helped developing this foundation. After this, we decided to start our own company in order to research and dive deep into the technologies and also of AI and OSINT, and trying to understand what actually can be leveraged realistically out of the current technologies into the investigations. How can we aid the investigative journalists, due diligence officers, law enforcement, also the military, and etc. Also, we are providing OSINT trainings. We are providing OSINT trainings for students from different areas, been training already for more than a year. We've trained hundreds of students. One of them of the courses was in the Robot Dreams Academy. And also we are providing trainings for smaller groups and individual trainings. And our mission is basically to give to the law enforcement, to investigative journalists, to civil society, to the business, the tools that are needed to mitigate the threats, to fight corruption, money laundering, and crime. And this is what we've been doing for the last year and a half. We also developing custom solutions for big organizations, for institutions when they are coming with their own problems or workflows that they want to implement. We implement this for them. So that being said, let's talk a bit about the agenda. First, I'll try to make a small introduction about the problem that we are trying to solve with our software, how the investigations can, like the process of the investigation can be automated in what way, and the challenges. A bit about the data standardization, the theoretical approach of the RAG for OSINT, retrieval augmented generation. Also, we'll compare different approaches between RAG and vector databases, and we will show basically I'll show step by step how could you build your own agent using different tools such as, for example, NA10 or GraphRag, not GraphRag, RagFlow, or similar tools that allow you to build your own agents and integrate your data into it. So let's jump in. Well, first, let me explain what RAG is. Probably you've seen or heard this idea already. RAG stands for Retrieval Augmented Generation, and basically what it means is that when working with the LLMs, well, from the very beginning, when you're asking an agent, be it the ChatGPT or any other tool, basically what happens is that you are working with the data that this agent was trained on, right? So we should keep that in mind in order to get actual answers. You need to be able to feed some data, some context to your question. Now, when coming to the investigations, this comes all the time. Like we have lots of data, all basically coming to us, and we, as investigators, are trying to disseminate it, to analyze it, and generate or write a report or be like an answer to a question, etc. So let's first talk return to the basic open source intelligence flow. First, what we are doing as investigators, we are planning and directing our investigation. We are trying to find the targets and basically what we want to achieve from this investigation. Second phase is the collection, gathering of the open source data in various formats. Then we're trying to process this data to make it smaller, to extract what do we need basically from it, to clean it, to structure it in some way, and so on. And after this, the analysis and production comes. We're trying phase. We are trying to find patterns. We are trying to find relationships between different entities. We are trying to tell the story, or basically describe what do we see and find interesting for us facts, and maybe it could be red flags. For example, if we are investigating an organized crime group, or for example a threat, etc. So we are trying to find these needles in the haystack. We are trying to understand how people, companies, organizations, groups are related within each other, and so on. So we're trying to tell a story, basically. And at the end, we are trying to remove the bias. We are trying to remove the basically the unfounded, right, opinions, etc. We, as investigators, at the end have to provide something that is built into the actual facts and data that are verifiable and reproducible. This is the important thing. So when we are trying to, when we are giving the results of our work, it's important to have every single source of the initial data. How did we find this? And this is important both for basically any decision making, especially it's important for the law enforcement, but also for pretty much any other area where OSINT is applied. Let's take an example. So let's say we have a person A that directs a company B. This company owns a domain. This person is associated with person C, who controls a wallet, etc. We are trying to find, let's say, a company that is legit, find out if, right, company B is related to a wallet that has been seen into a fraudulent behavior, for example, or is suspected of money laundering or relations to some organized crime, etc. Now, how a person, like an actual human being, not an LLM, would proceed with this? So first step, we would return to this, to planning, right? We would start the planning. We would try to find the targets being probably the company B, person A, and the other side. And we would try to gather as much information as possible, then remove this information and find the connection between them. Now, talking about the LLMs, this is not, so in order to build this pipeline, in order to reproduce it, we need to understand exactly how this data is being added, how is this data is being presented to the LLM agents. Because of course they are understanding the data in very different ways. First thing first, what we did is we tried to actually filter the user query. So when our software receives a query from the investigator, let's say Here the example is Viktor Grushan. He is an oligarch and one of the most influential people in Transnistria, breakaway region of Moldova. Let's say you want to have a due diligence report, right? With all the red flags, with all the information about his connections to different groups, to organized crime, maybe possible scandals, etc. Let's say you're an investigative journalist and you're writing an article about this. So what we are trying to do is first we get an example, we get the query from the user. In this case, find all information about Viktor Grushan and his companies. And what the LLM sees actually is conduct an open source intelligence investigation into Viktor Grushan and any companies or corporate entities associated with him. But also, actually, the LLM sees much more. We are adding more exact instructions on what we actually want to achieve. And we are trying to extract also the entities out of the user query. So when coming back to the data, okay, we want a report. Now we are trying to find data for this report. The problem with this is it starts immediately, right? Because where do you get this data? Now, as a investigator without any automation, how we would do it usually without any AI, we would just go to articles, go to the internet, trying to find as much as possible, gathering this data ourselves, maybe copy pasting, maybe trying to query some tools, for example, like open corporates or open sanctions manually, and so on. Now, if you want to automate this, first thing first would be gathering this data in a tabular or maybe graph format. So trying to crawl the websites, trying to extract the data from the IPs, for example, like open sanctions, open corporates, and so on. Trying to integrate the data from different tools that we are using during the investigation, such as Hunchly or Forensic OSINT, etc. Maybe we have some custom databases that we don't want to show to the world, but we have it. We want to extract data from there as well. And we need to integrate this all mass, these different data sources into one thing, into something that will allow us to extract this data in a meaningful way. So first thing that we want to extract, it's basically we want to separate this data into something meaningful, something that we can not only work with, but like have an actual format, logical format for this data, right? So the way that it's usually done in similar softwares or approaches is to separate them in entities, be it companies, persons, etc., and relationships between them. Ownership, maybe family ties, maybe, I don't know, a feud between them and so on. So there is a relationship between a company and a company, a person and another person, or another company, and so on. Also, there is the third data type, which could be considered an entity, but actually it's worth being separated in something separated. It's events. So you could also process your data into events and also analyze them separately in that sense. Now, let's say what first thing first, we open a tool like NA10 or any tool for building LLM agents, and we are trying to build the most basic pipeline, right? We have the user prompt, we are collecting the data, we have an agent that collects the data. So coming back to the processing, right, and the data, the collection, and how do we collect the data? We are trying to automate this as much as possible. And in this very simple pipeline, we first have an agent that tries to send the right queries to the tools, to the databases, or to data sources that we have. to crawl the website that we need, to send the right query to the SQL database, to the IP, and etc., etc. Second step would be to analyze this data, process it, and then generate the response, generate maybe a due diligence report, for example, about our case, give an answer based on the data that we gathered. And first thing we are trying to do is, based on the query that we already changed so that the LLM understands it's better, we are trying to extract the events, the entities, and the relationships between them. And that would be, basically would have different types of tasks. So identify and classify named entities, such as people, organization, etc., extract relationships, and extract event information. Thus, we have this basic data about the query. We didn't gather any information yet. It's just the task that was given by the investigator. So now, after this, we are trying to feed this data in a meaningful way to the LLM. We are doing this. We are gathering this data using this collection agent, and then we have a huge amount of data that is somewhat related to our query, right? We call it the haystack. Basically, the haystack, with everything we gathered about the targets, the relationships, the entities, and so on. And it's usually lots of data. We are talking about, maybe it's not a lot for the computer itself, but for the context window of the LLM, that's a lot. And what happens is that when feeding lots of data to an LLM, it has two struggles. Basically, has a problem with understanding long context. It loses critical details. If you're just doing a prompt engineering, like let's say, find the information that is needed from this data, and you're just putting this data into the prompt, it will not be enough. Most probably the LLM will have a problem with understanding all of this. It will lose focus. It will lose critical details that are so important in the investigation. Second thing is that the LLM loses focus. Basically, imagine this, right? Coming back to the data that we just had here. All right, I beg my pardon. Let's get back. So the idea is that if you're taking this data, let's say it's a JSON or just raw data from your sources, and you're trying to add this to the prompt, most probably you'll end up with nothing, because the LLM has a problem with understanding this amount of prompt, basically. And the thing is that in order to fight with this, well, we are trying to summarize this data. So for example, we are extracting this from one source. We are giving this summary, basically, of this data that we gathered, and for one source, and then the other one, and then the other one. And after this, we are giving the data to the analytics agent. Now, it's still a problem because the data is scattered in different formats. There is no inherent logic behind it. And basically for LLM, we are letting the analytics agent extract just scattered data, even if it's summarized in some meaningful way when we're trying to extract the important stuff. Now, question is like, how do we summarize it? In order to do this, instead of just summarizing it in text, we are trying to standardize it in one data format. It's called follow, like one of the examples in the industry is called Follow the Money, developed by OCCRP and Open Sanctions. First at OCCRP, then Friedrich Lindenberg, the founder of Open Sanctions, was one of the mastermind behind it. It's has become one of the standards in the industry, especially for investigative journalists. And this is one of the examples how you can work with this data, right? So if you're talking about follow the money, we have basically two types of data, let's say, be it an entity and an interval. Well, now intervals would be relationships between these entities. For example, here we have a director and organization. The relationship between them is a directorship. It started at some date and ended at some date. So we have some details about this. And we are trying to basically bring all the data sources into one format. That's the first step. Thus, we already can work with this data much easier. We don't have it scattered like between JSONs, SQL queries, I don't know, text, PDFs, and so on. It's one standard format. And this is how we do it, right? So coming back, the collection agent, we extract the entities that are needed for the tasks. And then we're extracting the results. We're passing this to the analytics agent and going to the report. Now we have a new challenge. Basically, we are trying to work over this data to make it coherent, to build relationships between them, to build a data graph. So for that, there are three steps. First, we find new connections. Basically, we're cross-referencing the data. Second, we are trying to remove the duplicates and trying to remove all dirty and unused entities and so on. And the third step, we are extracting separately some of these entities and their relationships that are relevant to our red flags. Red flags can be anything. It could be associations with several some entities. It could be something that looks like a money laundering scheme. It could be, for example, a group, organized crime group, and so on. And this data can be easily cross-referenced and such data graphs built. So the important thing when working with this kind of data is to focus, right? So these red flags allow us to give to the LLM some focus, which data is important, right? On which one it is important to focus. That's why when we are building this, see, we are giving the data graph and the basic data that we gathered, right? And the focused possible pathways for the investigation, where the LLM should pay more attention to, basically, in the generation of the report. And one of the examples how this can be done is building. So when we are doing this, we are also going through the LLM agent, which finds this possible path. Let's continue coming back to the knowledge graphs. Basically, we are trying to gather this data into one place, and it builds on itself over time. And yeah, we are using Neo4j for that. There are other alternatives. You could use other basically other approaches for that. It's not strictly necessary to build it on a graph database. That's one of the approaches that we've taken. However, this kind of relationships can be recorded into an SQL database as well. It really doesn't matter. The important thing is to be able to query this data efficiently. And we are talking about not the data that was collected all the time, right? Over time, right? It's the data that was processed, cleared, and something that we already know that will and can be useful for an investigation. Yeah, and also we are trying to separate the data based on two categories. So the importance, how important is this data according to our red flags, according to our investigation goals, and so on, and the trust. How trustworthy is this data? Is it verified? Is it like, can we be sure that this data is accurate, and so on? And yeah, talking about that, we are also trying to build over time basically an agent that allows us to work together with it. So not only chat with it, right, but also give it more data, for example, feeding the previous reports, feeding some thoughts about your investigation, right, trying to help it, and it helps us to conduct the whole research, because the more you're trying to work with the knowledge that you build over time, the more you gather, and you are ending up basically in the same place. You are trying to automate or like make faster your analysis of this data, and maybe return to something that you just forgot, or something that missed your attention, and so on. In that sense, Obsidian is an amazing tool. So it allows us basically to expand our reporting, our investigation workflow to the very end, and also helps us to make our lives easier on the very last stage of the OSINT investigation, on the reporting and dissemination. So this is how basically an example OSINT Obsidian workbook would look like. For example, here we have the example report on Alistair Camp. This is a person, and we see the data that has been generated or can be generated or added by the investigator itself. Here we are taking an example of the existing OSINT workbook. The links will be also in the presentation and in the email that we will receive. So here we see the basic information about the target, right? And also in Obsidian, we can build similar graphs to the ones in Neo4j. We can connect the documents between themselves. We can connect these entities. We can connect basically events, people, companies, and so on. And the agents, the LLMs, they understand this much better. When we provide the data in such a manner, it's much easier for it to work with. When the data is interconnected, it's not just raw JSON, or even if it's in the follow the money format, right? Both the human and the LLM understands this in a much more meaningful way. And talking about LLMs, it gives much better results. Also, sometimes we don't need to generate the entire report. We just want to ask stuff. We want to ask after the report has been generated, could you please tell me this or that fact about this or that entity, about this or that person, company, and so on. So what we've been doing is, that's an example of the generated reports in Obsidian. There is a tool that is used, basically a plugin. It's called remotely save, and it allows you to connect your Obsidian Vault with other applications, including with AI agents and tools like software like NA10 and such. And here we see an example on Russian mercenary, originally from Cote d'Ivoire. And we see that there are two types of data. So the first data is so-called raw data, the data that has been gathered from the sources. Second are the reports. And the third, basically the third folder, should we say, would look something like that, right? So it would be managed and written by the user itself. And when asking a question, the LLM will take into account the data that was provided by the user, the data that was generated before and the data that was gathered before, but in a different way. It will consider the data that was given by the user, by the investigator, much more important, much more trustworthy than the data that was generated, and the data was generated well, much more trustworthy and coherent than the data that was just gathered. So you have three stages, right, of how the LLM perceives this. And here is another example. So we, for example, this is one of our early tests. Basically, we have an UI, thanks to the open UI, through which we connect to our AI agent. And for example, we are asking who is Victor Gushan. Now we made it in such a way that when asking who is and then the target name, it generates a due diligence report, basically generates a full report based on the sources that we have. And what happens under the hood is that basically the entire workflow that we just showed you. So first thing, the entity Victor Gushan is extracted. Second thing, the this entity, this name is being searched to the sources. The resulting data is being processed, the red flags are applied, it is being added to our knowledge base, and after this, we extract the most important facts that in the end go to the analytics engine, and it generates this kind of reports. Also, another idea how you can integrate this, like think about the tools that are coming, talking about the sources. You could also integrate this type of agents with tools, for example, like Hunchly. For example, Hunchly has this amazing possibility to capture the data during your investigation. You're gathering all of this, like the emails, the notes, for example, that you're doing during investigation, etc., maybe chunks of texts and so on. And then you want to add this to this knowledge base of the LLM. You can forward this to our API. Basically, it integrates this back into it integrates it into the knowledge base, which is quite cool. This kind of things can be done with different different tools and softwares, not only Hunchly. There are other examples. There are lots and lots of APIs with different data use cases and so on. The important thing is to be able to process it. Hunchly, in that sense, is a bit more unique because it allows the investigator to go over the sources themselves, so gather it over time and then pass it to other, basically to our workflow. A bit about the LLMs and the challenges that we've been fighting all the way, and actually there is huge room for opportunity right now. So we see new models coming in, we see new integrations coming, etc., new softwares, new solutions. And the cool thing is that you can develop much more and make it much more exact, more ethical maybe also, and actually have this data much more reproducible and accurate without any hallucinations, without any bias, and so on. And this is basically the frontier that we see right now in this kind of integration. There are some companies that are having a great success, but there's definitely a lot of room for improvement and for research. And this is what we are trying to do. So we are trying to create this pipeline that will be accurate, that will give results that are reproducible, and that will help the investigator find the pathways in the research, basically find the needle in the haystack. Also, I really recommend you to research it in general. And one of the latest inspirations for us, we've been the ideas that we just talked about. Basically, we've had it some time ago, but recently we stumbled upon this amazing paper written by a team of researchers from Tsinghua University about memory, knowledge integration, tool application, and self-recollection for an LLM OSINT agent. The links will be added as well to the webinar materials. Really recommended that you go over it. I think this is one of the most fascinating research papers that we found on this topic. But also there are lots of other companies and communities where you can ask more about that research and such. And yeah, please contact us. Here's our email.